Hello, and welcome to this OpenTopography tutorial. My name is Chelsea Scott. In this video, we'll be looking at how to visualize and how to use topographic profiles to better understand an area's underlying topography and urban structure. We'll be specifically looking at urban areas. So to begin, what is a topographic profile? So on the top figure here, you see the cityscape of Auckland, New Zealand. And you see a lot of typical features, such as a building, a road, and a bridge. And we can use topographic profiles as a different way to view this landscape. In the bottom, this is a topographic profile that shows elevation versus distance. And the red line is the elevation of the recorded from the digital elevation model across this red line here. So this shows a lot of bumps, and these bumps are buildings. For example, this building here is going to be approximately here. And we can use the topographic profile to measure the height of the buildings. For example, this building here starts at just over 40 meters elevation and goes to about 75 meters elevation. So we can very precisely measure the elevation of different features on the map. We can also see the underlying geology of the city. For example, we see here there's a hill. So in more detail, why should we compute topographic profiles? We can use these profiles to visualize buildings and the urban landscape in cross-section. So in particular, we can measure the height of buildings and look at their shape in the direction of the topographic profile. And also look at the underlying topography. For example, we saw that hill on the last slide. And if we put topographic profile following different roads, then we can see the slope and the direction of that slope along those roads. Profiles are often quite useful for looking at vertical change. In particular, we can really precisely measure the change. For example, we could measure the change of buildings from an earlier building to a reconstruction in that same area. And these profiles allow us to measure and visualize that change, often much more precisely than with maps of elevation change, or versus clicking on individual points. So we are shortly going to go to QGIS and look at topographic profiles along digital elevation models and from a map of topographic change for these two data sets located in Auckland, New Zealand. The first was acquired in 2013, and in differencing literature, this is called the compare data set. Second was acquired in 2024, and in the differencing literature, this is called the reference data set. We do have other videos focused on how to do topographic differencing and compute topographic hillshades. So I'm going to skip over that part in this video. All right, so welcome to QGIS. I have now displaying the topographic change map here, the reference topographic hillshade from 2024, and the compare topographic hillshade from 2013. So to visualize topographic profiles, the next thing we need to do is install the profile viewer. So I want to come in up here to plugins and say manage and install plugins. So click that and we'll search profile tool right here. And then we'll click install plugin. So it is now installing. So there we go. tool is successfully installed. So you'll then want to come here, back up to plugin, and you can say Profile Tool, Terrain Profile. And we'll click that. And then this viewer is going to come up at the bottom. And we can now set up our profile in the way that we would like. So first we're going to look at topographic profiles of the reference and compare data sets. I mistakenly drew that profile line, but let's add in some layers first. So first we'll want to add in the reference. So we want to be sure to click the reference digital elevation model, not the hillshade. So we can say then add layer, and we'll then highlight the compare and say add layer. And so they're both red, which isn't super useful to see them apart from each other. So we can click one of those red boxes and then select a different color. So now we have these two topographic profiles. So let's first see where something changed. So you see here we have this building. This is now looking at the vertical differencing map. See the color scale. So red or blue indicates an increase in elevation. So this is going to be an increase in the height of the building. So let's put a topographic profile through this area. So we can click to start the profile. We can click again to select a different point. And then we can click again, yet again to end or to select a different point along our profile. And then we can do a right click on Windows or control click on Mac to finish our profile. So here we have our profile and our two profiles. The reference is in the red and the compare is in the blue. And it's not super useful yet because we have one point here in the red that brings down our y-axis. So let's put it at, we'll say -10. And these are going to be in meters or the same data set, same units as the data. And then we also can see that the top axis is a little bit too high. So we can bring that down to 70. So now we've got a fairly decent set of topographic profiles. And in particular, here we see the red, which is the reference. So that's that second data set. So areas where the red is higher indicates an increase in elevation. So for example, we can see here that there was likely a building or so beforehand, and that building got replaced by a much taller building, which is the one that we can see here in the red outline on the topographic profile. And if you look in the building on the vertical change map, then you also see that red dot, and that's showing you the location where you are in the topographic profile. And we can use this to very precisely measure the change in height as well as shape of any new buildings. And we could also add a map of, or a profile of the topographic change. So we'll select the vertical differencing. We'll say add layer. That's down here at the bottom. Let's make that green. And again, we still can't see it because we're really, the y-axis is impacted by this negative point down here. So let's take both of them from 70 and then -10. All right, so here we can see now we've added the vertical change, and where we have vertical change, for example, here, see this represents an increase in elevation between the acquisition of the two LiDAR data sets. And we have the option of saving this, so we can come here to graph, we can select the file type, we can go save as, and this will let us save the PNG of this topographic profile. that we have just made. Now I'm going to show you how to do one last piece. So we can come here to Table. We can select Table. And then we can say Create Temporary Layer. And we have the option of doing this with any of the 3 data sets that we have. So let's, for the demo, let's do it with the reference topography data set. So we'll say Create Temporary Layer. And then you'll see this just popped up this set of points. So we can zoom in and see now we have this set of points. And this is actually now a shapefile that is a shapefile with the elevation of each point along the topographic profile. And so if you want to extract or export the elevations along a topographic profile, coming here to saying create a temporary layer, and then exporting this shapefile to be sure that you save it is a really useful way to be able to save the elevations along your topographic profile. Thank you very much. And this concludes our video on looking at topographic profiles in urban areas.